In this third and final video on Introduction to Financial Math, we're going to look at bonds and mortgage payments. And really, all we're going to do to talk about bonds and mortgage payments is to use a couple of the formulas that we have talked about in the first two videos. In the handout that you can download, see the link in the description below, I've got this list of formulas from video 1. Those are the ones above this red line, and the ones from video 2. And in order to talk about bonds and mortgage payments, we're really just going to be using the basic present value formula, and we're going to be using the present value of a perpetuity and using those ideas to derive like we did last time. We're not going to re-derive it. We're just going to use this idea that if you look at an annuity, which is a stream of payments that stops sometime in the future, as opposed to a perpetuity where those payments theoretically keep going forever, that in order to figure out the present value of that, the common sense way to come up with that formula, you're not really memorizing much of anything, is just to consider that an annuity is a perpetuity that stops. So you can always think about the present value of an annuity as the present value of a perpetuity, but then we have to subtract off what is the value of losing that infinite stream of payments at some point in the future. And so that's just the perpetuity formula for present value, and then we subtract off the present value of that same perpetuity at n periods in the future. And as we did last time, we just simplified that. If you want a simplified, easy to use formula, this present value interest factor of an annuity formula is very important. But if you ever just need to come up with a formula and you don't have the present value interest factor of an annuity formula handy, then you can always just go with this common sense way. Payment over R minus payment over R, and then take the present value of that. So when we talk about bonds and mortgage payments are really just annuities, and bonds are just annuities with another payment that you receive in the future. So let's start off talking about bonds. So in order to understand a bond, really you need to know three things to talk about the present value. What should I be willing to pay for a bond today? So you need to know the face value. The face value is how much is going to be paid back to you in years. So if it's a 30-year bond, you buy the bond now, they're going to give you that face value back that's listed on the face of the bond back in, say, 30 years. But then also most bonds have a coupon, an interest payment that they make throughout the life of the bond. So some periodic payment of money. So we need to know the nominal or stated, or sometimes it's called the coupon interest rate. And that interest rate is used to figure out how big is this payment they're going to be mailing me every month or every 6 months or every year. And so we're going to call that amount of money the payment that they're going to be sending us periodically. The third thing we need to know is if I were to invest my money somewhere else, not in this bond, but in some alternative investment, we need to find something that has a similar kind of riskiness to the bond that we're considering buying, so that we're trying to compare apples to apples here. And it's usually going to be something different from this coupon rate. So the coupon rate is just something that's listed on the bond, and it may or may not, and probably isn't, exactly what the alternative investment rate for similar assets would be. And you'll get a picture of this as we go through. So we think about this as the opportunity cost since I'm an economist. If I have my money tied up in this bond, I could be earning some other amount in a similar kind of asset. So this one is a $5,000 bond, and so that is our face value. That is not necessarily what people are going to be paying for this bond. It's related to it, but it's not the same thing. We're going to be calculating the present value, which is like the fair market value. What should these things be going for? So sometimes people pay face value. Most often they don't. Now this bond that we're looking at is actually quite old. This one was issued in 1976 in the United States. And the interest rate, now this is the stated or coupon rate, is 8%. So what that means is that per year, this bond will pay you 8% interest on the face value, $5,000. Whether you pay $5,000 for it or not, again, is kind of a different issue. And this is a 10-year note. So it is issued August 16th, 1976, due August 15th, 1986. So it's a 10-year bond. Now, interestingly though, this interest, this 8% interest, so 8% of $5,000 would be $400, right? $400 per year. But that interest on this particular bond is not paid yearly. It says down here that the interest is payable on February 15th and August 15th. So it's paid semi-annually, twice a year. Even though this is a 10-year bond, we're going to be thinking about this bond as being a 20-period bond, 26-month periods, and therefore our interest rate isn't going to be 8%. We're going to be thinking about this as a 4% interest rate bond. This is because it's 8% per year, it's 4% per half year. It's going to be N equals 20 periods. And then the payment amount each period is going to be not $400, but it's going to be $200, right? It's going to be 4% of $5,000. So the payment equals $200. Now, these bonds used to, and some probably still do in the world, come with coupons on the bottom. That's why we call it the coupon interest rate. So a coupon is a physical object attached to the bottom of the bond, and this isn't all the coupons that would go with this bond. There would be 20 of them. And here we just see 4. And each of these coupons has a different date on it when you can turn it in and get your interest payment. And they say $200 each, and it's got the identification number and the date and all that kind of stuff. Tear off the coupon, mail it in, or take it to a certain place, and they'll send you your $200. Now, these days, of course, a lot of this is just done electronically. So what we haven't talked about yet is the prevailing interest rate. So that if we wanted to calculate the present value, what is this bond worth if it were to be issued today, we'd need to know what the interest rate is today that we could get in some other asset to compare with. Now, we're going to do that in a few minutes, but before that, let's just do some kind of standard textbook problems to try to get some patterns under our belt and talk about what the formulas look like. Now, there are many different kinds of bonds out there. There are zero coupon bonds that have no interest payments in the intervening period. There are some bonds where they will separate the coupons and the bond, and they'll sell those separately. But the standard, most common kind of case for a bond is it's got these two parts. Part one is an annuity. The annuity is the stream of payments, that $200 we were looking at in the previous case, plus there's going to be a lump sum, the $5,000 in that bond we were looking at, that's going to be paid in N years or in periods. And we want to think about it in a general case where it could be months if these payments are paid monthly, or years if they are paid indeed yearly. So really we've just got two parts to the formula. We want the present value of the annuity, so I just wrote our previous formula for the present value of the annuity. And then we want to take the present value of that FV. Now, FV usually stands for future value. In this case, we're thinking about face value of the bond, which is the future value that will be paid to us in a certain number of years' time. So let's do a couple of standard textbook problems here to get our feet wet. So let's suppose you buy a $1,000 face value bond, and it's going to pay you 4% interest at the end of each of the next 30 years. Okay? Plus, the end of 30 years, you're going to get the $1,000 face value back. How much is it worth if the prevailing interest rate is also 4%? So in this case, the payment is going to be $40 per year. It's going to be 4% times $1,000. So we have $40. It's going to be paid to us each of 30 years. So the present value of that annuity, 1 minus 1 plus R. Now, R is not the 4% coupon rate. It's the 4% prevailing rate that we could get in an alternative investment, okay? They're the same in this case, but most of the time they won't be. So we got 1 plus 4%, so 1.04. And then that's raised to the minus 30. And then we divide that by that 0.04. Same 0.04. And then plus, we're also going to get that $1,000 back 30 years in the future. So we just want to take the present value of that amount. So the $1,000 we'll get in the future, 1.04 raised to the 30. And again, that is that same 4%. So let me write that in red so we know that's the 4% that we're talking about here. The annuity part, just the present value of the stream of $40, is going to be $691 and about 68 cents, but we'll use some more decimal places there. And then the present value of $1,000 30 years from now, about $308.31, but let's bring in an extra decimal place here. Now, what do we get when we add those two numbers up? $1,000 precisely. The reason why the present value of the bond is equal to the face value is because the interest rate this bond is paying us and the alternative interest rate we could get somewhere else are identical. In that case, the present value of the bond will be equal to the face value. But again, that's going to be kind of a rare occurrence. Sometimes they're close, but they're very rarely exactly equal. And let me just remind you one more time. Any time when we're thinking about present value, what we're trying to do is answer the question, how much money would I need today in order to replicate the stream of payments that this investment will pay me? And what this $1,000 is telling us is if we can earn 4% somewhere else, then if we have $1,000 today and we put that in the bank paying 4% interest per year, then what we could earn every year at the end of each year is $40 in interest for 30 years. And then at the end of 30 years, we'll still have the face value, $1,000, in the bank, right? So it's the same stream of payments. Now let's look at what happens when those two interest rates aren't the same. What if the prevailing interest rate was 7%? Then all we do is we change the 0.04 to 0.07 everywhere in the formula in these three places, 1, 2, 3, and then we recalculate. What is the present value now? How much money would I need in order to replicate this stream of income? $40 paid to me at the end of every year and $1,000 at the end of 30 years. Well, we're going to need less than $1,000 because less than $1,000 will be able to bring us $40 interest every year since we can earn 7% in a different investment, even though this bond only pays the 4%, right? If we put these numbers in our calculator, what we get this time is the present value of the annuity, just the stream of $40 for 30 years, is $496 and about 36 cents. But again, just for accuracy, we'll include an extra decimal place there. And then the present value of $1,000 30 years in the future, in other words, how much money would I need in the bank now so that it will grow to be equal to $1,000 30 years in the future, would be $131.36, or 37 cents if we round. So the total, when we add those two streams together, $627 and about 73 cents. Now, I really like calculating the value of bonds like this and doing these two pieces separately because, again, there are bonds out there where people will buy the bonds and they'll split these two parts, literally split them in two, and they will sell the coupons separately from the face value part. So we would call this face value part a zero coupon bond, and then this stream of $40 payments just becomes an annuity, right? So here's the big lesson that you have to understand if you want to understand bond prices. Anytime the interest rate out there in the market goes up, the value of bonds goes down. A lot of people say that bonds are a very safe investment. I guess they are, but only if you intend every single time you buy a bond to buy it and hold it until it matures. If there's any chance that you're going to buy a bond and then maybe later sell it, they're not a safe investment. Because as we see, the interest rate going from 4% to 7% can decrease the value of the bond that you own quite a bit, from $1,000 down to $627, right? That's a big decrease. It's just as risky to hold bonds as it is to hold stocks, in my opinion, because the value can go up, the value can go down. Now, just one more example here. What would happen if you had this same exact bond, but all of a sudden, the prevailing interest rate, the interest rate that you could get with an alternative bond or an alternative investment out there somewhere, was now only 2%. You know the drill by now, so I'll just go ahead and calculate the answers. So in this case, because you have an asset that pays 4% interest, but everybody else in the market is only earning 2% interest, that makes the value of this bond much higher than the face value, because this bond pays twice the going rate of interest. So that's going to make it a much more valuable asset, okay? So let's talk investing strategy. If you have the opportunity to buy a bond today, say it pays 4%, and you think that interest rates are going to go down tomorrow for some reason, maybe the government is going to change their policy to lower interest rates, then buy that bond today, because when interest rates go down, your investment will be more valuable. So if the going interest rate today was the same as the coupon rate, 4%, you would buy this bond for $1,000, and then tomorrow, when the interest rates drop, you could sell it for $1,447.93. Or you could hold on to it and just have a better stream of income coming in than you could get in any other alternative investment, okay? You don't have to sell it. Let's go back and look at that bond that we looked at a few minutes ago. What would the present value of that example bond from the 1970s be worth? Suppose that for some reason the United States government issued an identical bond to that today with 10-year maturity, paying 8% interest per year, but paying it twice per year. Let's write down these numbers that we need to plug into our formula. The payment was $200 every 6 months. And so N is 10 years times 2, since we're talking about semi-annual payments, 26-month periods. The face value of that bond was $5,000, which will be returned to you at the end of the 26-month periods. And then what should we put in today? And by today, I'm saying March 2021. Well, I went and looked and said, well, what are other 10-year bonds paying for their yield? And the 10-year yield on bonds, yield meaning if I pay whatever the bond will cost me, what is the equivalent interest yield that that bond will earn over its lifetime, is 1.525% per year, okay? And so that interest rate that we'll want to plug in is going to be 1.525, but that's per year. So we have to divide that by 2, right? But then we also want to write it as a decimal as we put it into these formulas. So we're going to want to divide that by 100. So the value to put in there, we could either call it 0.7625% or as a decimal, 0.007625. So if you feel like it, pause the video real quick and calculate the present value of this bond and see what you get. So because the coupon rate on this bond is so much higher than what interest rates are currently in the United States for similar kinds of bonds, instead of being worth anywhere close to the face value of $5,000, we're getting a number closer to $8,600, right? So again, when the prevailing interest rate in the market goes down, the value of existing bonds goes up. Okay, let's look at mortgages. Most mortgages are actually simpler than bonds because you think about mortgages as just a stream of payments. So it's really just an annuity in most cases. However, it has been fairly common in some places around the world for there to be a balloon payment. Now, a balloon payment means in addition to paying a certain amount per month to the bank for a mortgage, at the end of the term of the mortgage, you also have some fixed amount that you have to pay them then in the future. And so if there is a balloon payment, then it is going to be more like just a bond. Here, I'm going to assume that there's no balloon payment and that your payments to the bank are just like an annuity. If that's the case, then to analyze a mortgage, all you need is this formula for the present value of an annuity. So, simple problem. Suppose somebody told you that they had just bought a house and their house payment is $800 every month and that their interest rate is 3.75%. And that this is a 30-year mortgage, which is common in the United States, so that's going to be 360 months. How much did the house cost? Really, we're just plugging into the formula here. So first, the payment is $800 times this present value interest factor of an annuity formula here is 1 minus 1 plus R. Okay, the interest rate is 3.75%, but that's not the interest rate we're going to put in this formula because this is an annual percentage rate. We need to convert that into a monthly interest rate. So we have to divide that by 12. In your calculator, first, say convert it to a decimal, which would be 0.0375. Divide that by 12, right? The interest rate we'll use in the formula is 0.003125. So 1.003125 raised to the minus 360, right? 360 periods. So we're talking about how many months is it? It's a monthly payment. It's got to be a monthly interest rate. So all those things in the formula have to agree. Monthly payment, monthly interest rate, and N is the number of months. And then on the bottom, we're just going to divide by that same interest rate, 0.003125. So if we just calculate that present value interest factor of an annuity term in the brackets here, we get 215.9288, which tells you that for every $1 the house payment is, that the value of the house is going to be about 216 times as much, right? So it's just how much is your payment, multiply it by 216, that gives you how much you borrowed from the bank. And when we put all that together, the value of this house would be about $172,743.05. So nothing really out of the usual from what we've done before. It's just a different kind of annuity. Now, most of the time, people want to do kind of the opposite of this, right? They don't want to calculate the value of a house knowing the payment. What a lot of people want to know is, how do I calculate the payment if I know the interest rate and I know how many years it is and I know the value of the house? So that's this final problem here. Suppose we wanted to buy a house for $180,000. Okay, a little bit more than in the previous problem. And the interest rate is the same amount, 3.75% per year and 360 months. How much would our payment be? All we really want to do here is take this formula and solve it for payment, right? So when we do that, all we want to do is just divide both sides of this equation by this present value interest factor of an annuity. And then on the right-hand side, these two will cancel, just leaving us with the payment. And then over here we have the present value, the value of the house, or how much money you want to borrow from the bank, divided by this present value interest factor of an annuity formula. A very common way that people will write this, however, is they will, instead of dividing, they'll turn it into a multiplier, and that means they'll just invert this fraction here. So they'll put this on the bottom, they'll put that R on the top. When you divide by a fraction, you invert and multiply. That's all we're doing here. There are two kind of common ways that I see this payment formula written in textbooks. One is kind of what we just did there. Another one, instead of having the negative n exponent, it'll have 1 over 1 plus r to the n. Exactly the same thing though. As always, I encourage you to pause the video and I'll show you my work in just a second. So really, since we're talking about the same interest rate as before and the same length of time, then all we're doing is dividing by that same present value interest factor of an annuity, right? We have to get the same amount. So we're just dividing the value by that 215.9288, and we get a payment of about $833.61. So why did I make this series of videos? Why take my time to make 3 videos on basic financial mathematics? I do this because I want everybody who wants to be able to easily understand where these formulas come from. And I'm kind of an uppity economist. I used to teach classes in money and banking, and I would have about half economics students in there and about half finance majors. And the finance majors never wanted to know, never wanted to understand the formulas. They say, oh, well, I have my financial calculator. Can't I just use that? My answer is always sure, but if this is your degree, if this is your area of focus is finance, these formulas aren't that hard. And the way I used to teach this to my students is the common sense way. Instead of memorizing those simplified formulas, I came up with this Berkey United formula for asset pricing. Again, I'm not claiming I invented this. I know a couple of other people who are economists who, when they've taught similar classes, this formula just comes out of common sense. But it's not taught this way. It's not taught using commonsensical ideas. They teach you the simplified formulas most of the time, and then you're left to wonder, where did that come from? So instead of memorizing a lot of formulas, all you really need to do is know two. Payment over R is how you calculate the present value of a perpetuity. And that one, in video 1, we demonstrated a very common sense way to understand where that comes from. And then how to take the simple present value of an amount in the future. And that's just take that amount in the future and divide it by 1 plus R to the n. And then from those two ideas, you can calculate the present value of bonds, you can calculate mortgage payments. It just takes a little bit of algebra and simplification to derive all these other formulas, because here you have the present value of an annuity, and here you have the present value of the face value of a bond or a balloon payment or whatever, if you need to add that in. So mathematics is not magic, and it doesn't need to be mysterious. You can do this. As always, if you have any questions or you have suggestions about other things you'd like to learn, this is really not my area of expertise, but it's fun. I like making this stuff a little simpler and easier for people. But if you have any requests, as always, let me know, and if it's something I think I can do, I'll definitely put it on my list. But as always, thank you so much for joining me, and have a great day.